Hello everyone. The problem we're looking at today is from the same contest as yesterday is the USACO 2023 US Open Contest Silver Problem 3 this time, Pareidolia. So this problem I also kind of struggled on during my mock contest, but well, I think it's easier than the last one. Anyways, the problem statement is still very straightforward. You get a string and then Farmer John tell you this phenomenon called pareidolia, in which you see familiar objects in patterns that doesn't exist. For example, a face in the cloud. And Farmer John just keeps seeing Bessie in the strings. For example, when he sees this, he can see Bessie, right? Because Bessie and Bessie. So you can't. Basically, it's like a sub array. A subsequence. There's a word. A subsequence in which it's not continuous, but you can't change the order. You can only like erase a few characters, and you can't add. You can't change the order. And now you're trying to find the total number of Bessies that can be made across all substrings of the input. So not just the input string, but all substrings. So for example, for this thing, you need to find the sum of all be all Bessies across this part, and everything. Okay, so there's the length of the string is at most, I think it's 3 times 10 to the fifth power. So basically 10 to the fifth power. So now you can pause the video and think about the problem. Okay, I would say it's pretty difficult, and I'm just not gonna go through my incorrect solution during the contest because that solution made this whole thing 187 lines long when the actual code is only like, let's see, 30 lines. So yeah, I'm gonna be posting this whole thing in the comments if YouTube even lets me post a comment that long, and then you can just, if you actually care, you can look at my incorrect solution that I did during the mock contest, which I mean it can be educational to make educational mistakes. Anyways, so I'm just gonna jump straight into the correct solution. So ignore the cussing here. We're gonna mathematicalize the situation here, and basically we have sigma L from 1 to n and sigma R from 1 to n, right? Because then LR is just every single substring, and then BLR just denotes the function that represents the maximum number of Bessies that you can form in the substring of L to R. So this is then the answer we're looking for. And notice, even though the solution said I shouldn't know this, but I didn't know this, is that if we switch the order of the two sigma, so for each R, the sum of every single BLR. So we basically have a fixed R. So we find a fixed R first, and then we iterate through every single L before it, and then we find the sum of all of that. So we basically have like a DP state. Fi means the sum of all the BLI. So for this fixed I, we go through every single L from 1 to I minus 1. So Fi is just the sum of BLI for every single L from 1 to I minus 1. So according to the solution, it's that. But I mean, it felt kind of weird even to me back then, which I was very oars back then. I'm just going to say that. And it fell off by a lot. I'm very washed now. Anyways, now we need to find the last Bessie in the first I characters. And we need a micro DP. It's actually like a mini DP. Actually, 6 mini DPs. So if AI equals B, L1 just means the last place in which this character existed. So LA1 is for B, LA2 is for E, LA4 is for S, and LA5 is for LA4 is for I, and LA5 is for E because it's BESSIE, right? LA is just the first I characters of Bessie appeared in the index of the B of this Bessie. Yeah, I don't really understand that either, but I was very oars back then, so I'm gonna trust my oars self back in December 31st of 2024. Hey, this is actually the last problem I did in all of 2024. That's pretty good. Anyways, so obviously if it's B, we can do a transition. It just starts in I, and if it's E, then we transition from the last one because obviously. And notice that we have to do this transition before we do that because otherwise we might do 2. And also this one, right? No, actually, the order of this would not matter because after you transition the 1 onto 2, it would not actually influence the 5 to 6. But after you just did 2 to 3, and then you do 3 to 4, this 1e could be viewed, this 1s could be viewed as 2x to your function. Well, it's actually just 1. So you have to do this first, and then you do this. I mean, this. I think I already lost a lot of people, but anyways, if you're still following this, it's just like that. And then quite obviously, I was pretty worse back then. It's not obvious to me anymore, but now we know where the last Bessie started. And notice that the contribution of this last Bessie to the region ending at I is just LA6, right? Because think about it, the Bessie that ends at I, we must choose I. And then there's LA6 ways to choose the starting point in order for this Bessie to contribute to such region, right? So you might just like, I did have a question here. The last Bessie must start at LA6, but it doesn't have to end at I. So we actually have more than one choice for the right end, and this Bessie still contribute to the region, right? Well, that's correct, but don't forget our initial assumption. Fi only means, okay, I lost that. Okay, Fi only means the sum of BLI, which means we're fixing the right end at I. So, bro, where is it? Our initial assumption, we're computing the prefix sum of BLR for all else, for a fixed R, right? So we're still forced to choose I as the right end because we're only computing the region with right end R equals I. So finally, there's one more, there's only, what the heck? So only the contribution of the last Bessie. What about the ones before? Well, if you know anything about DP, or at least the fact that DP never makes sense, you should be able to figure out that Fi equals FL6 minus 1 plus L6. What? Oh, yeah. Fi equals FLA6, which is the starting point of this Bessie that's already ended because it's 6 minus 1, starting point minus 1 because you have to choose a starting point, and the plus LA6, that's the number of ways to choose the starting point. No. Okay, yeah. So you have this, you have FLA6 minus 1, which is the number of Bessies that you can choose from before the starting point, and then you have the number of Bessies, number of contributions made by this last Bessie. That's the number of contributions made by the first Bessies, and that's the number of contributions made by this last Bessie. And yeah. Okay. So one last step. Yeah, promise. It's actually the last one this time. You have to take the sum of all F, and I hope you understood why, because otherwise you probably didn't understand a single thing I said. Because remember, Fi is only the number of Bessies ending at I. So of course I have to take the sum of all of it. So then, yeah, this is still back to the time period when I still wrote a giant default source, and well, the real code is how many lines? Real code is 16 lines long. Okay, that's pretty abstract for the code to be 187 lines. But anyways, yeah, this whole thing is super straightforward once you understand it, but it was not obvious to me. None of these steps were obvious to me, and they're still very confusing to me even now. So if you can understand this process, good job. You're more worse than me. Anyways, hope you understand this video, and hopefully after this, at least you know how to solve this problem, even if you don't really understand how to figure out the solution yourself. At least you kind of know how to solve it. And yeah, thank you for watching, and I'll see you tomorrow. Okay, for the grind report today, yeah, it's an actual video. We actually have a grind report today. So if you're just here for the problem review, you can go ahead and click out. That's all. I know it's very confusing, but it's life. It's USACO, guys. Anyways, the grind report for today, I did a problem. Yeah, that's good enough for me, I guess. And also, I worked on a very classic one that I probably should have solved, but I haven't because, well, it requires high accuracy algorithm, and it's the Kingdom game or whatever, the P1080 on Roku, which is a pretty classic problem for greedy. I'm kind of focusing on greedy right now because there's a bunch of greedy stuff that I don't know about. And also I'm practicing my high precision multiplication and high precision division, high precision comparison. And yeah, I'm very rusty around the edges. That's just this whole thing is a freestyle. It's like rapping, and there's like so many bugs. Well, at least we're restarting. Okay, at least I made a video today. Okay, thank you for watching, and I'll see you tomorrow.